Alien messages may have reached Earth. Why haven't we detected them yet?
For decades, scientists have been scouring the sky for signs of extraterrestrial technology, using radio waves, light flashes, and infrared emissions.
Despite all this effort, no confirmed signal has been found. A new study from EPFL in Switzerland proposes an intriguing explanation. It is possible that messages from alien civilizations have already passed by Earth without us noticing. The problem isn't necessarily that the signals don't exist or haven't reached us. What may be happening is that they have simply escaped our detection capabilities. A technosignal, any observable evidence of advanced technology, such as artificial radio transmissions, laser pulses, or excessive heat from giant structures, needs to meet two conditions to be discovered. First, it has to reach Earth. Second, our instruments need to be able to identify it. Often, even when a signal arrives, it can be too weak, last only a few moments, be on a frequency we are not monitoring, or get lost in the background noise of space. This means that, over the last 60 years of SETI searches, the search for extraterrestrial intelligence, it is quite plausible that several signals have crossed our region of space unnoticed. Theoretical physicist Claudio Grimaldi, from EPFL, analyzed this possibility using statistical models. He calculated how many signals would need to have passed by Earth since 1960 for us to have a reasonable chance of detecting one now, and where these signals would likely come from. The study considers both signals that spread in all directions, like the waste heat from megastructures, and more directional beams, such as lasers or interstellar beacons.
The results are revealing and somewhat discouraging for those who expected a quick discovery. To have a good probability of detecting a technosignal coming from relatively close distances, a few hundred or a few thousand light-years, an extremely high number of signals would have to have already passed us by unnoticed. In many simulated scenarios, this number is unrealistic, greater than the number of habitable planets that would exist in that region of the Milky Way. Detection becomes more realistic only when we broaden our perspective to much greater distances. If the signals last a long time and are spread throughout the galaxy, then messages coming from several thousand light-years away could be picked up by us. Even so, the expected number of detectable signals at any given time remains very small. This view changes the search strategy. Instead of waiting for strong, nearby signals, the future of SETI will likely depend on continuous, large-scale, long-term observations covering vast regions of the Milky Way. The absence of detections so far does not mean that there is nothing out there. It may simply indicate that the signals are rare, distant, or long-lasting. In short, alien messages may actually have reached Earth. The challenge lies in honing our listening skills and having the patience to search further and for longer. The discovery, if it happens, may require a more persistent and comprehensive approach than we imagined.